Hey, happy Sunday. This is PFG Live, the podcast that wants you to control everything and measure almost nothing. Welcome aboard. We've got Evil's jumped right in there, and he says it's about 23 science out there somewhere. Josh in southern Manitoba says it is currently winds are 250 at 1 knot, temperature 14, dew point 13. Remarks are confusing. Let's see. We got CJ Stevens is with us. He says hello, and 83 degrees and beautiful in East Tennessee. Gobble gobble. So I got to show you. I could slide down here. There's Mr. Gobble. If you're watching the screen, this is CJ's friend, Mr. Gobbles. Tucker says it is partly cloudy and 64 in Ludlow. He is on the move, a moving target. And here in the Windham, New Hampshire, it is currently 69 degrees, 48% relative humidity, and winds are out of the southeast at 5 miles an hour. Manchester Airport reporting winds are 200 at 4 knots, visibility 10 miles. Few clouds at 5,000, broken at 25,000, temperature 20. Dew point 06, altimeter 3032. Nice and dry today. Beautiful day. Dale is reporting from Edmonton, 20 degrees science and sunny, 44% relative humidity in the north of the America. You're not wrong. Let's see. Everybody's checking in. So we might have a little bit of a light day today. I don't know why. The vibe is that everybody's outside instead of inside, which is okay. It's totally fine. We forgive you. So just check in as you come in, grab a finger sandwich, and make yourself at home. There'll be drinks. It was an interesting day of hacking. Oh, Bill Olney is here from Rome, New York, where it's 74 degrees Frankenstein, sunny, and 43% humidity. Welcome, Bill. Nice to see you. Orjan is with us, reporting from Echo November, Victor Alpha, where the winds are 240 at 14 knots, no significant weather, light rain, few clouds at 2,500, scattered 3,200, broken 3,800, and temperature is cold, 10 degrees and 7 degrees on the dew point. The altimeter is in metric. Yeah, welcome from Norway. Let's see. So this week was getting my act together with Home Assistant. And it's funny, as soon as I created a Home Assistant channel on the Discord server, I discovered how many people knew all about Home Assistant. So we're going to talk about that today. And as per using it as a tool in the shop, because I think it's a magnificent tool. Then I'll tell some stories about that as we get underway. Let's see. We had some fun things happen this week and this weekend. Mr. Tucker, who is in the chat, he is mobile, so he will not be joining us. But Tucker and family visited here. They had a social engagement down the road, and we had a very nice visit. We had a very nice sushi dinner with the whole family. I posted some pictures on the Discord server, and that was a good time. Plus, I delivered. Let's see if I have a picture of what I delivered to Mr. Tucker. Let's see. This was a visor for. Somebody remind me the name of the character. What's the name of the character? I know you're driving, Tuck, but you could pull over. It's one of the Marvel characters. But anyway, he's doing a cosplay, and we had the good opportunity. Master Chief, thank you, sir. Yes, okay, good. We had at least 2 people who are up on their comics. So this was a Master Chief visor. I'll give you the big slide here that I printed in FormLabs Clear, and it came out really lovely. The best part is it just barely fit in my curing station. A video game character from Halo. Thank you for tuning me in on that. I apologize if you're a Master Chief fan and I offended you. So it fit, and it came out spectacularly well. So happy to have been able to help the Master Chief, and we will, I'm sure, be seeing more pictures of the Master Chief coming soon. We also had, so this morning, just this morning, I was kind of getting my brain started, and I got a text message from none other than Dr. Marv, and he did not know, by the way, Tuck, I know what you're thinking. He did not know you were here showing me his product. So if you don't know who Marv is, we did a PFG.Live with him several months ago, and we're due to do it again. So Marv, if you're listening, let's pick a date. But Dr. Marv is now working for Kern, or as we say here in the United States, Kern, and is a really super good resource for understanding how things cut, how materials work, and he's doing some fun things at Kern, and he came out with his own line of precision knife sharpening stones, which work with the knife sharpening jigs, which are becoming popular. So when Tucker was coming over, he says, "Oh, I got to show you these things." So he brings over the kit that he bought from Marv and showed me the results, of course, on a Grimsmo Rask, and fantastic results, just beautiful, literally mirror finish on the blade edge. It was beautiful. So I had a long conversation with Dr. Marv, and we had some fun talking about products. And of course, naturally, whenever you talk about making magnificent products for this community, we had to talk about shipping because that's the bane. In fact, his words, which mirror mine, was it was the bane of his existence. And we're talking international shipping, of course. So we had a nice chat. Marv, we'll get you on. Let me know what's good for you. Test Room is checking in. He says, "Good evening from Oostkapelle, Netherlands, 13 degrees science and 75% relative humidity. Welcome." So let's see. Tuck, Dr. Marv, we'll probably remember some other folks as we go along here. Bootstrap Garage is with us from Waterloo, Ontario. 26 degrees science, 52% humidity, and good afternoon to you, sir. So you're, I'm not sure, I don't recognize the name, so this might be the first time you're on here, but we're starting to get some traction in Waterloo. I think that's good. I see a new area of fans in Waterloo coming together. So this week, the big win was getting home automation up and running. We should call it shop automation because there's some fantastic tools in this thing for what we're doing. So let's just review some of the history here. CJ Stevens is waving at you there, Bootstrap. Harvey Newman is with us. Hello from Santa Rosa, 71 and lovely. Isn't it nice? It's a wonderful time of year. I almost fell asleep on the back porch this morning. It could have happened. So if you go back in history, you will recall, I'm showing on video, the Featherboard workstation that I designed using the Adafruit Featherboard. There in the center is our favorite SHT45 from Sensorion, mounted on a little sensor board that Adafruit makes called it's a Stemma QT board that has the sensor on it, and of course a lithium-ion battery. And this had been running quite successfully. Yes, it's full of SHT. That is correct, and it's the 4.5 model of SHT. Just want to point that out. So in the past, we got that up and running, and then we started using two different services, one called notify.sh, which is a little bit of a technical kind of service, but you can you would shoot messages out to it, and it would store them, and it was great. And then the second thing was Adafruit IO. So Adafruit, the manufacturer of these boards, also has a service called Adafruit IO. And as we now understand, we didn't understand it then, it's an MQTT broker and service. So MQTT is a protocol. Anybody know what that stands for? Evils has to know what that stands for. And for a long time, I was using MQTT to Adafruit IO, and there we go. Message queuing and telemetry transfer. MQTT, which we will now call MQTT. So it you were able to make a screen, make a dashboard, get graphs and curves of all your stuff, and I was monitoring relative humidity in the machines. And that worked really well. But one of the issues was it was a little hard to do exactly what I wanted it to do. I wasn't able to use the information. I was able to log it. I was able to look at the graphs. And I was able to pay $10 a month because I was using it above the free level. So recently, Evil says, no transport. Yeah. So recently, I don't know how I got turned on to this. Somehow Home Assistant came on the radar. And Home Assistant is an open source, very well supported software package and system for like everything. So you could tie all sorts of things into Home Assistant. So I got pretty excited about this. And my friend Adam Brunette, who is possibly, is he listening? He might be listening on YouTube and I wouldn't know it. But Adam, he has a bunch of Home Assistant stuff running. I probably heard about it from him. And he has automation running through Home Assistant for all sorts of things around his casa. So I looked into it, and in fact, I called up Adam and I said, "Hey, Adam, can you run Home Assistant on a Windows machine? Because I have basically a server in the basement that's really a number cruncher that I use for running my antenna simulations, but it's also running some little scripts." And I figured, what the heck, if I can get Home Assistant running on that, that'd be great. And Adam says to me, it would be easier, far simpler if you ran it on a Raspberry Pi. And I said, well, I have a Raspberry Pi. So I dug through the Raspberry Pi drawer. Paul, welcome aboard, sir. Paul Morley says, for the last 8 years, I've been using Home Assistant and MQTT to log many, many things around my house. I absolutely swear by it. I'm late to the party. What can I tell you? So I dig around looking for a Raspberry Pi, and I find 2 Raspberry Pi 2s, and thankfully 2 Raspberry Pi 4s that I had kicking around. Art That Makes Art is with us. That's Wes. He says, I use Assistant to turn my air compressor on and off. It has a timer, so I don't leave it on. Awesome. Josh asks, can it log where I left my keys? Yes, it can. So I got out one of these Raspberry Pi 4s. I found myself a 32 gigabyte SD card, and I forged ahead. Ted says he started with Home Assistant, then migrated to OpenHab, Coke and Pepsi, got it, since it picked up InfluxDB and Grafana early in the game. Both are close in the comparisons. Beautiful. And Evils is basically spinning up his own MQTT stuff, and he doesn't lose his keys. So I'm all excited. I go to the Raspberry Pi website where I recall that they had a piece of software to generate an operating system on an SD card. Well, I find it, and sure enough, it's wonderful. You hit one button, you put your SD card in your card reader on your computer, and it will blast an operating system onto the SD card. I plug it in, I bring up the Raspberry Pi, I talk to the Raspberry Pi via SSH, and now I'm ready, right? So I don't have the Home Assistant. I know how to. So I call up Adam. Oh, Adam was busy. I couldn't find him. He was busy. So I go over to a good friend of mine. I don't know if you guys know my friend. His name is Chat. He's been around here. So I go to my friend Chat and I say, hey, Chat, how do you put Home Assistant onto a Raspberry Pi 4? So Chat starts blathering, right? Telling me all sorts of things. And I'm like, it says, go to the Raspberry Pi website. And I say, yeah, I got that. And it says, go, install this and hit the, and I did all that. But then I saw a screen that didn't look familiar, and I read very carefully, and it said, push the button that says install a Home Assistant system. I utterly had no clue. So you go to raspberrypi.org, you get their little tool, and you go find in their menus, there's a button that says just build a Home Assistant server. I hit the button, it created the card, I shoved the card in the 4, I plug it into my network, and I was done. That's how hard it was. So once I had the Home Assistant server up, I was able to start messing with it. So I proceeded cautiously, and the next step was I needed to get information into it from my Featherboards. Well, I already had software written, and in my software was the capability of publishing to an MQTT server, because that's what Adafruit IO is. So I start hacking this, and I start using my friend Chat as a resource. And I did something for the first time, and it was a convergence of my knowledge coming up to speed and ChatGPT's capability coming up to speed. And I said to ChatGPT, hey, listen, I want to get this code talking to Home Assistant. And I think it said something like, well, show me the code. So I took the whole piece of code, which wasn't like ridiculously huge, and I dropped it into ChatGPT, and it said, oh, okay, well, you see this section? Yeah, throw that out, grab this section, you take this section and replace. Anyway, I follow all of these directions coming from my friend Chat, and I start getting results. And sure enough, in reasonably short order, I started getting publishing to happen. And I can see my data starting to get to Home Assistant. And now I got unreasonably excited. So the next step was getting a dashboard to work. So inside of Home Assistant, you can make a dashboard, and it's way nicer than what I was experiencing on Adafruit IO with their dashboards. Much more control, very well refined. So I was able to create a dashboard. If you're watching on video, I just put my dashboard up on the screen. And I created one of these little fuel gauges, and it started working. And I started building it out. So I have 4 Featherboards currently up and running. Each one is running the same. Actually, it's not exactly the same software. 2 of them have to get updated, but they're all running just perfectly fine. And this is live, by the way. So if you're watching on video, there's a bunch of fuel gauges in front of you, right? So the left column is the charge of the battery. You'll see the bottom one that's in AMS1 right now needs a charge. The middle column is relative humidities. Number 3 The third one down is literally sitting right here. That's the one we're playing with. Let's see if I blow on it. We'll see if the relative humidity comes up on the next reading. They're only reading every 15 seconds, I think. So those are the relative humidities. You're also able to set up these danger zones, right? And the red, the yellow, the green. And on the far right is just temperatures. So it's just reading the temperature. You can see that the coolest temperature here is down in the basement in the 3D printing lab. So this stuff's all live, and it's working just, stunningly well. I could not be happier. So the follow-on steps were all tweaking the software. Oh, Max is here. Hey, Max. My buddy Max, who's on the West Coast, says that Claude AI has been much better than ChatGPT for code. Well, to be honest, I haven't tried Claude yet, but I was using, just for reference, ChatGPT 5, and I have no complaints, but I'd be happy to go try Claude one of these days. It worked, and I got very, very nice code running now, to the point where in the last couple of revisions, of cycles of reviewing the code, we started looking at battery efficiency, because that's a big deal. And and one of the things I solved when we first started playing with the featherboards, especially this featherboard, which has the reverse TFT screen on it, was I had to make sure that the screen was off and I was using as little power as possible, but also how to put it into a deep sleep. So there were two kinds of sleep. I know I'm getting into the weeds here, but some of you guys who have played with these featherboards will understand. There's two kinds of sleep on these ESP32 processors. One of them uses the real-time clock, and it's just like a timer. Well, that uses current. Not as much as not sleeping, but it uses current. There's a deep sleep where it has a teeny itsy bitsy hardware timer, like an alarm clock. And getting that to work was non-trivial. I mean, it was probably 5 lines of code, but they were very hard-earned 5 lines of code. So when we finally got that working, we got some super good battery life. I mean, I could let this thing run with this battery pack probably for 3 months, which I think is pretty good. So, we got some tweaking done with my friend Chat, and when it was all done, it was very clean code, and it was running really well. Paul is showing on the screen one of his dashboards in Grafana. Yeah, it looks great. Isn't that awesome? So that's when we arrived at the big, all the dashboard stuff working, and that was literally 48 hours ago, I think, when everything was really cooking. So that's the measurement. So in my case, it was getting our existing Sensorion board on the existing featherboards running. And I have a video and a section on the links page at pfg.gg/links. If you'll rummage around in the links page, you'll find the featherboard stuff. Well, so then my good friend Doug Chin, who I have mentioned before, and he was sort of the origin of the low airflow idea. Doug said he was having success with these boards from Yolink. So Yolink makes a little temperature humidity board or box with a nice LCD display, and according to Doug, they're using the SHT series of Sensorion sensors, which is our favorite sensors. So I bought, for research purposes, the hub, the Yolink hub and a few of the temperature humidity sensors. And I have in AMS number 1, as you can see over here on the bottom line across is AMS 1. I have a featherboard. But wait, I had 2 featherboards, but now I moved it to AMS 2. Then I had 2 of the Sensorion evaluation boards, one black, one blue, and I now put the Yo-Link in the same box. So we had 5 sensors in the same AMS, and I have to say that the Yo-Link was performing very nicely. So I had 2 Yo-Links up. I have 2 Yo-Links up. One of them is inside of AMS number 1. The other one is a room sensor, and that is sitting right next to the top row, KP1. And they agreed very nicely. So if you want a no-fuss thing just for monitoring and you don't want to mess around with the featherboards and you don't want to screw around with software and stuff, you can go and just get these Yo-Links, and they work. They're accurate, and they're using sensors which we know will go down to low humidities. The problem is it won't fit in the AMS. There's no place to put it because of the form factor of the box, which is sort of a bummer. But they do work, and they do a good job. So it's sort of a backup. It's giving me a commercial unit to kind of look at. We may keep it. I may stop using it. We'll see what happens. I know also that DBX. DBX is in the chat. DBX is running the Yo-Links also. And wait for it. If you go to Home Assistant, you can hit a button and it will integrate the Yo-Link interface right into Home Assistant. So even if you were running Yo-Links, but you want to play with Home Assistant, you can make them work together. I tried to get that working just before we went live, and I didn't have time. But I'll tell you about another. They call it an integration. So there's a Yo-Link integration in Home Assistant. I'm sorry I don't have. I might have a picture of the Yo-Link. Let's see if I have one. I took one knowing I was going to talk to you about it. Yeah, here it is. So there's the Yo-Link on the right labeled Y2, and next to a featherboard, which is KP1. And on the far left, not the far left, but almost falling off the shelf is the Yo-Link hub, little tiny thing. And that is their speaker hub, by the way. Part of the automation, you could have that thing making sounds and noise and talking to you and listening to you and doing all sorts of stuff. So very nice product if you're not going to mess around with software and such. And it will integrate with Home Assistant. So I could recommend that if you wanted to mess with this stuff and you went with those, you're not going to go wrong. So I had a way to measure relative humidity on the AMSs. Now, why did I care about that? So let's tie this all back to our low airflow drying system. So the low airflow drying system, which is pictured here, is dependent upon compressed air being dried and then using that dry air and feeding it to the AMSs. We want to be able to monitor the humidity in the AMSs. We have been doing that so far with the little Sensorion boards, which you could buy from my store. I stock them. And in a case and a bracket and stuff for the AMSs. So that's been very successful using them as monitors, but we can't use them in automation. So the next step is going to be adding the featherboard's output, going to Home Assistant, and then Home Assistant making some decisions based on the observed relative humidity inside the AMSs. So before I get past this slide, I just want to point out the last thing I did on the system is added 2 gauges. On the right is the input air gauge, which is about 120 psi, as one would expect. On the left side is a much easier to read gauge on the manifold pressure feeding all of our tubes, and that is sitting at 5 psi, which, by the way, is lower than it's been the whole time. So we've been lowering the flow rate, not the pressure, I'll explain in a second, the whole time, and now it's sitting at 5 psi. So let me explain where we started here, and then I'm going to circle back to the automation stuff. The original low airflow concept used a regulator, just like you see, and it went into a manifold, but it went into the manifold at some elevated pressure. We were using about 10 pounds going into the manifold, and then it used needle valves. And I showed these part numbers from McMaster Carr. So here's a very nice needle valve that screws in, has a 1/8 NPT connection. It has a very nice needle valve with a lock nut on it, and then it's the 1/4 inch, push on connector. Nice part. It's about $15, I think, for each of these. And this is what I was running for about a week to great success. The echoes. This is making me want to replace the echoes we barely use. I don't know what the echoes are, sir. You can tell me. Todd says, I've had some really good success with the ESP home integration in Home Assistant. It even works with PoE-powered ESP boards. Easy way to monitor or control. Thank you, Todd. I appreciate it. I am aware of this thing called ESP Home, but that's about it. So probably a lot of what I'm doing with the ESP boards is done in ESP Home, but I don't have any personal knowledge. Amazon Echoes. Yes. Yeah. Well, check out the Yolink thing. I think you could do everything you want without an Amazon Echo. There is an Echo in here. So those were the needle valves. So let's review. We had 120 psi, downregulated to 10 psi, going into needle valves. After the needle valves, going into tubes leading to each of the AMSs. Okay, this worked last week. I reported on it. This worked spectacularly well, and we were running absolutely sub 15% relative humidity, generally sub 10% relative humidity, and the ultimate in our control jar, it was measuring roughly 7% relative humidity. Very happy, great system. But one of the challenges is I looked at that system and I'm like, I have 7 things here that need to be adjusted, and I want to keep them the same. And it seemed kind of crazy. And I said, it would be better if we had fixed orifices, not adjustable, and then we adjusted the overall system flow with the pressure. So I said, it's too bad you can't buy a fixed orifice to replace an adjustable needle valve. Well, what the hell did I know? Because the next thing that happened at a company that we know and love, McMaster Carr, I go and I find these orifices. And if you look on the back of this, if you're lucky enough to be on video, this is a plastic housing with it's actually nylon, with an 1/8 inch NPT female on one side, the push-in 1/4 inch tubing connector on the other side. And on the back is a little brass thing that's screwed in. And if you look real close, I don't know if we're going to be able to do this on our video here. Probably not. But there is a 10,000ths hole drilled in that brass part. So here we have, for a few bucks less than a needle valve, a fixed 10,000ths orifice. And that's what I wanted. So I switched the whole system now. So now we have the high pressure to low pressure regulator. We have the manifold. And then we have 7, in this case, 7 10,000ths of an inch diameter orifices feeding the tubes. I then added the very nice gauges to make it easy to look at. So I've picked 5 PSI now, even lower, okay, as the standard, and it's working quite nicely. And it's still running about 0.0. It's less than 0.02 CFM per line. I think it's actually about 0.15 CFM per line, and that's working out quite nicely. So that's where that's the status of the low airflow system, and the magic were these little orifices. So the goal is to observe the system, observe the humidities in the AMSs, and then I could decide what that manifold pressure needs to be to keep everybody happy. Now, naturally, if it was high, it would go quicker. If it's low, it goes slower. And there is a long time constant associated with moving the relative humidity, especially if you put some filament on a spool inside that is already a little bit moist. Evil says, does this mean you can't adjust per downstream load? Correct. So that's my design choice. In other words, I can use the adjustable needle valves and adjust each one for its downstream, flow, or I could have it fixed. I choose fixed because reasons, and I'm going to make it all better in a minute because I know that makes you crazy. You say an adjustable needle valve could be kept at a fixed adjustment and still work with a gradually lowered source. Yeah, absolutely correct. It could still work. I didn't have to replace the needle valves. I chose to replace the needle valves. One of the reasons is when you look at them, you can't tell what their setting is. So now that I've fixed all of the settings, I know what it is at all times. So I looked at flow indicators for low flow rates, and they exist. In fact, I don't think I mentioned it on the live. I think I mentioned it in chat last week, that this is an oxygen flow meter that I was given by my friend Doug that has the little floating ball in a tube. I have a floating ball in a tube downstairs in the welding department, which I use with helium. A bubble counter is a good idea. There's all sorts of ways to do it. I have a better idea. If you can't make it good, make it closed loop, okay? So now we have measurements of the relative humidity in each of the AMSs, right? Well, if you look at this picture again, if you look at the far right side, you'll see the big gauge, the big high pressure gauge, and there's a T, and then to the left of it is the high to low pressure regulator. Right there, I am going to put a solenoid valve. Okay, I'm going to put a electrically operated solenoid valve that I can control, and we're going to set up some rules for automation that says, if you have this condition, turn the system on. If you have this condition, turn the system off. So this is like the simplest automation that I can imagine. If I put in a solenoid valve that is running at wall voltage, 120 volts AC. I could then control that voltage, and if all of the humidities are below 10%, for example, what do I need the system on for? Turn it off. And if all the humidities, if any of the humidities are above some value, pick a number, 15%, turn the system on. Super simple. And then I can have a flow rate that is appropriate. And I'm guessing that how I have it set up right now is just fine. And this will further reduce the air usage. And there's only one piece left to make this all work. So in our house, we use Lutron for our lights and scheduling and scenes and dimmers and all that stuff. We use the Lutron Cassetta system. Yeah, it's basically PWMing. That's a very good description. Hey, Lewis is with us. He says it's 10 degrees science and a clear night. You got to give your location or we don't know where it's night. And I remember you from last week, but I don't remember where you are. So tell us where you are, Lewis. Yeah, we're PWMing it. Absolutely. And the big knob on the regulator is the height of the pulse. And the system will turn it on and off with some hysteresis. Oh, you're in, yeah, Glasgow. Welcome aboard, sir. So this morning, no, it was already afternoon. I go downstairs. I did some hacking upstairs. I didn't say anything. I went downstairs and I had some lunch, and I ran to the basement just before we went on the air, and I put a fresh roll of filament into AMS number 1. Now, AMS number 1, as you will recall, is being carefully monitored here. All right. It's the bottom row. Right now, it's sitting at a lovely 12% in the green. Everything's cool, right? So when you open the AMS and you put a brand new roll of filament in it, which, by the way, came right out of the oven, I will point out that's my procedure now. So right out of the oven and right into the AMS, I was standing by the door to the garage, and I got excited, very excited, because the light in the vestibule turned on. So I had written an automation that says, if the relative humidity in the AMS goes above 15%, turn on the vestibule light to the garage. Because it was a placeholder, okay? And then 10 minutes later, 15 minutes later, guess what happened? It went below, I think I have it at 12% or something like that. It went below the threshold, turned the light off. So we have the next step working. We have an automation, and now all I have to do is, instead of turning the vestibule light on and off, I have to turn a solenoid valve on and off. So Joshua Furman, welcome aboard from FirmWorks. Sorry I'm late. Listen, we don't mind you being late. Just come in quietly, hang your coat on the rack, help yourself to some finger sandwiches, and welcome. So the next step was, how am I going to switch this solenoid that doesn't exist? So I went to McMaster Carr, of course, and I found a solenoid, 120 volt AC solenoid, ready to go. And I'm going to replace that little piece of pipe between the black regulator and the little T connection there. I'm going to put the solenoid right there. And then what's not obvious is right below that ancient telephone jack on the wall is the AC outlet. So we're going to plug a thing into the AC outlet, which is going to be the switch, and then that's going to plug into the solenoid. What's the thing that's the switch? Well, Lutron makes a magnificent, very rugged plug switch. So it has a plug on one side on a short length of cable, and it's got an outlet on the other side on the short length of cable. And I use two of them right now in the shop. So one of them turns the mist collector for the Okamoto grinder on and off. The other one turns the heater in the Okamoto grinder coolant tank on and off. And I've been using those for remote control, and also it allowed me to put one of their little remote control widgets on the panel of the Okamoto, so I could just reach up and turn on the mist collector. So I have a lot of experience with those units. So we're just going to buy another one of those units. And yes, they're more expensive than if I use some other cheap one. But it's the same thing I'm using throughout the shop, and that's going to be controlled. But it's a Lutron thing. How do it's Home Assistant. It's not Lutron. Well, guess what? 3 buttons later, my Home Assistant system has complete control over my Lutron stuff. Okay? It was so easy. You go to the integrations section of Home Assistant. Home Assistant says, by the way, buddy, I've mapped your network, and there's a Lutron hub sitting right there. Would you like me to integrate it? So I said, yes, please. It says, go push the black button on the back of the Lutron hub. So I went downstairs and I pushed the button on the back of the Lutron hub and counted to 3, and boom, everything in my Lutron system was now controllable and accessible from Home Assistant. Man, was that easy. CJ Stevens is reminding us to make sure you hit the like and subscribe buttons. Thank you, CJ. And no, you can't do that in Home Assistant, okay? You have to do that in YouTube. Like, subscribe, do all the things. And I appreciate it. Thank you, CJ. CJ is my like and subscribe reminder. He's better than automated. Ted said, if your Lutron doesn't integrate nicely, which it did, I recommend an inexpensive Sonoff, which is S-on-off remote plug-in outlet, since it will integrate directly to Home Assistant. I will look at those because I am interested. If I didn't have Lutron already in my system, I would do this straight away. Blah, blah, blah. He provides a link, and it's called Sonoff, S-O-N-O-F-F, Sonoff S31 Wi-Fi smart plug with energy monitoring, 15 amp smart outlet. There you go. So if you don't have Lutron stuff, you could just buy one of those, and that's probably, how much is it, Ted? Was it 15, 20 bucks? $7. What a country. I can assure you that the Lutron thing is more like, I looked at it before. Well, it's double-digit dollars. I don't remember how much it was, but it was like $70 or $90 or something. But yeah, thank you. We will make that available for everybody. So, do you see the whole system now? We have the low airflow system, which has been proven to work beautifully to keep all the filament dry. We're going to have a solenoid valve controlled by Home Assistant. We have Home Assistant monitoring all of our relative humidities. And then we have the ability to write this almost arbitrarily complex rule for when to turn the system on or off. And essentially, I just described my rule, which is if any member of the low airflow team goes above a certain limit, just turn the system on. And when it goes below another limit, which has a little hysteresis, turn the system off. So that's the next step. It's coming. I don't know when I'll have that up and running, but I will be placing my order for another Lutron switch tonight and a McMaster car order for that nice little solenoid. I have enough power cords here to wire that up, and we'll be on the air. So it's going to be we might have that done before my good friend, Mr. John Betancourt, also known as Geek Gamer News. Let's see, I had a couple of pictures from our project. Let's see if I could find him. He is my professional plumber, and he helped with a bunch of the air system. Here he is working. There he is. There's John working away. And just did an outstanding job on the system, and I couldn't be happier. So thanks, John. I appreciate it. And if you're a geek and a gamer, go to Geek Gamer News and subscribe. So that's the status of the low airflow dry air system. I couldn't be happier. Now, there's a few things also going on. One of them is, if you go back to when I said at one point we had 5 different sensors inside the AMS, Unix Carbide says, you've hit a new low. Thank you. Thank you so much. We try. We do try. When I had 5 sensors in one AMS, I was able to observe different sensors reading what I thought was the same air. Okay. And I was getting a range of readings. I think the highest reading I was seeing was 12.5% relative humidity, and the lowest reading I was seeing was like 6.5% relative humidity. One of the sensors are a little suspect, and that's the blue Sensorion board, which is the oldest of all of them. And it's possible that it's been contaminated. Now, what do I mean by that? The Sensorion sensors, let's take a quick detour, talk about the Sensorion sensors. They work by measuring the capacitance between 2 plates with a dielectric between them. That dielectric is capable of absorbing moisture, and its dielectric constant goes up, increasing the capacitance between the 2 plates. When it dries out, that dielectric constant goes down. The water molecules leave the dielectric, and the capacitance goes down. And they make an oscillator on the chip that uses that capacitor as the timing element. It's actually brilliant. But there are some materials that you can get into that dielectric that are not water, and they don't want to leave. And one of those is, our common solvents, isopropyl alcohol, et cetera, and that there's some of that around. So built into the Sensorion chip is a heater, and you could fire off a heating pulse, which is pretty hot, for 1 second via software command, and it will clean out the sensor. And if it's a really bad case, you could do it multiple times with appropriate spacing, and you could reset the sensor. The problem is that in commercial products like the Yolink, even some of the other, pretty much any ones that use the Sensorion, I don't know of not one that actually uses that feature. And I use that feature on my feather boards. If you push and hold one of the buttons when it comes around for a measurement cycle, if it sees you holding that button, it fires off that heating cycle. So I have to do that, and you can't do that with the sensor that's on the eval board. They didn't provide for that on the eval board. I'm kind of bummed about that. So I might do something like hit it with a hot air gun, et cetera, but having said all of that, it is a potential source of error. So, okay, setting that one aside, there's still a variation between all the units. We were joking about this before. Man with 2 watches never knows the correct time. Man with 2 quantum mics never knows the correct measurement. So, we have to understand that the variability. So then I said, well, I wonder what the sensitivity to this relative humidity number is. And it turned out, I asked my buddy Chat to do the calculation. I reviewed the calculation. It turned out that it only takes 1 degree C to move the relative humidity count by about 3%. And you guys can check me because I put that into Chat in 3D printing. No, in the low airflow thread. Yeah, okay. So it's a pretty sensitive, relative humidity is a pretty sensitive number when the temperature changes. So one of the things that's going to be different is that the different places in the AMS, they're going to have different temperatures. Not by much, but if it's 1 degree, that's 3% of relative humidity. Yeah. Ted says, important first word, relative. So the second thing is, and you may recall if you were in our after party roundtable last week, Mr. Renzetti brought this up. The air is very stagnant in the AMS. So if you stir it up, you will get more accurate readings by mixing the air. So I gave this some thought, and I went looking for some potential little fans, and I found the cutest little fan. If you're on audio only, I will describe it to you. But there it is for our friends watching the video. This is an 18 by 18 millimeter fan, and I think it's 4 millimeters. Yeah, it's 4 millimeters thick, and it's a 5-volt fan. And no, I have not had time to play with it yet, so I haven't fired it up. But what I'm thinking is that it would be very easy to integrate this in our next version of widget that goes into the system. Evils ask, have you considered using a resistor instead? Of course, you could use a resistor. That's not what we're interested in doing. All you're going to do with a resistor is create a temperature gradient, which is going to further screw everything up. Ted says, that's not an 8-inch optical flat. That's correct. Let's not get as if there's nothing else going on here, right, Ted? So there's some possibilities there for mixing the air and making the measurement. So we want to make a measurement. We don't want to change the measurement. And the whole idea is that we're not using heating. We're using the low flow air to do the job. So if you move the decimal point over, as we were joking earlier, when you have your quantum mic and you're trying to make a measurement, one of the easy ways to make the measurement, more reliable is to put some black electrical tape over those extra digits after the decimal point. If we start thinking in terms of, maybe a 1% resolution, maybe less, all of a sudden, 12% sounds pretty good. Anything below 15% is pretty good. Now things start to just work and get comfortable. So we'll see. We'll see what happens. But I wanted to show you that little fan. It was kind of cute. And we'll see if that is useful. If it doesn't actually move a useful amount of air, then it might not be worth it. But I think it will. This, by the way, is, you may recall this from in our quest for dry filament, we discovered these little things, which were designed by somebody to hold desiccant. So this is a little desiccant box, which fits with maximum efficiency into the front of the AMS. And what I'm doing is I'm using this shape, this volume, as the potential for building the next widget to go into the AMS. That is basically what our featherboard is currently modeling. Here is a smaller processor, which I've shown this before, but this little teeny processor here, which I can cover up with my index finger, okay, you can see the size of that, and here's our SHT 45 sensor. These two guys would do everything we need to do that I'm currently doing with the featherboard. We don't need a display, so that doesn't have to be there. And if we fit those two little guys into this volume, which is in the front of the AMS, we have plenty of room for some beefy batteries. We have plenty of room to stick the sensor, as high up as possible. And we might have plenty of room to add our little fan. Okay? So that's sort of what's rolling around in my head for a widget which can go in there and do all the jobs we need and keep our filament dry. So I think that's the story. That's where we're at with the low airflow system working great. We're measuring all the humidities. We know how to do that now. The software is solid. And yes, I will make it available when we settle down, if anybody wants to copy it. Now, as a final note, why put this effort in? We put this effort in so that we arrive at an automation that completely eliminates my job. And my job was running around checking desiccants, checking humidities, replacing desiccants, putting a new roll in. Oh, I got to put the desiccant cartridge in the middle of the roll. Oh, I have space in this AMS. I'll throw a couple of extra cartridges with desiccants. Oh, that desiccant's not working anymore. I'm going to pull that out, dump it in the recharge bucket, put in more. This was like a never-ending cycle, which was effective. It was kind of working. But honestly, the number was 20%. I was fighting to keep everybody happy under 20%. And right now, as I sit here talking to you, there's two different AMSs. One's at 10.3, one's at 11.6, and I don't have to do anything. And that's a pretty good thing. The one adjustment I did also, I forgot to mention, is I changed my compressor from running between 115 PSI and 125 PSI, which is a 10 PSI band, okay, to running from 105 PSI to 125 PSI, which is a 20 PSI band. So the compressor now is running less frequently, but for longer, which is healthier for the compressor. Fewer start cycles, hotter oil, all good. So this is all working toward getting me out of a job. I don't want to be Mr. Humidity. So I think we've pretty much arrived. The next update on this project will be when we get the solenoid valve in and the automation working, and we'll get to a point where we can call it R1 instead of P1. I think we're at about P3 right now. So that's the story. I'll give you a quick update. We got 2 orders in the queue. Those are going out soon. One of them is a custom bevel. You know who you are. Inventory is looking pretty healthy in the PFG Stones. Tucker was here and walked out with some more Sensorian boards, but we still have a couple of those. So if you need something flat, head on over to pfgstones.com. Pick yourself up some PFG Stones. You will not be sorry. They are flat, and that's where it's at. I think next week, I got to double check this because I want to make sure we don't have a problem with next Sunday. And no, we should be okay for next Sunday. So looking forward to seeing you guys next Sunday on the PFG Live. If you have any questions, comments, or snide remarks, don't hesitate to send them along in all the usual channels. And most of all, get flat, stay flat, and dry. We'll see you guys next week.